Hi, I'm Steven Spielberg. You've seen me in such fine quality epic films as Charles Law and You, and Honey, I Blew Up the Lab, Part 2. Today we're going to be looking at the second gas law that we had talked about in class, which is called Charles' Law, named after the French chemist, who was also into hot air balloons. Now, unlike Boyle's law, what Charles did, he did experiments with gases, but he kept the pressure the same. He wanted to know what would happen with volume and temperature, which, if you think about it, that kind of has a connection to hot air balloons. But anyways, so when we look at the formula for something like this, the formula for this is V1 over T1 is equal to V2 over T2. Okay? Now, since the pressure is the same, we don't have to worry about P. Now, when you look at a problem like this, for example, you don't have a pressure. It doesn't mention a pressure, which is great because the pressure is the same. And that makes things much simpler. So here's our problem that we're going to work on. It says a gas syringe contains 42.3 milliliters of a gas at 98.15 degrees Celsius. Determine the volume that the gas will occupy if the temperature is decreased to 18.5 degrees Celsius. Well, let's take a look here for one thing. I want to look at what are the pieces I want. So here's a piece of information I want, and then here's the other piece of information I want, and it's done in red, and it's volume, okay? And I look for temperature. Well, I have a temperature here, okay, and I have another temperature over here. Now the question comes down to is, well, which one is which, okay? So when we look at something like P1 and V1, I mean, not pressure, sorry, T1, sorry about that. It's T1 and V1, and here's T2 and V2. How do we know which one is which? Well, the thing that you have to look at is you have to look at the sentence itself to see, is there a connection, is there a hookup? And sure enough, for this one right here, we have a hookup, we have the word at. Okay, so we have 42.3 milliliters, hence, that's a volume at 98.15. So guess what? The 42.3 milliliters is connected to the 98.15 because that at is what's connecting. This volume at that temperature. That temperature with this volume. Okay, so at is the key word there. At. So I know that these are connected to each other. So it doesn't matter if it's T1 or T2, V1 or V2, as long as you keep them in the same place. So here I'm going to make this 42.3 milliliters. Let me do that in red. Okay, I'm going to do that in red so you guys can see. So here is 42.3. Okay, now over here for V2 it says determine the volume. When they say determine, that's the word that says, hey, you gotta find that volume now. So, okay, that is our question mark. We don't know what that is. Now we do have temperature, and the temperature, I am going to put that in green, and my temperature 1 is 98.15 degrees Celsius. Temperature 2 is 18.5 degrees Celsius. And you may notice something. Can we work with Celsius on this? No, we've got to work with Kelvin. Well, why? Because Kelvin doesn't go into the negative, whereas Celsius can. So it's a good habit when you're working with something like Charles' Law, for example, that you work with Kelvin temperatures, because that's what it was designed for. Okay, but wait a minute. How do we change the temperatures? Okay. Well, the way to convert Celsius to Kelvin is to add 273 to the temperature. So, 273 plus 98.15. And we have 18.50 plus 273.00. So now we're going to convert. We're now converting our temperatures from Celsius to, now does it matter if I put which one on top? No, it doesn't. It's still going to come out the same. 11, 1, 8, 8, 9, 17, 1, 2 is 3. So for our temperature 1, it's 371.15. And here, 3 is 11, 9. And then the second temperature, which is definitely lower, is going to be 291.5 degrees Celsius. So, wow, we have got some definite temperature changes here. Okay, so what does that look like for us? Well, that means, ladies and gentlemen, we can now, we've got our information, we've got our temperatures, because here's T1, here's T2. Now we can take those numbers that we worked so hard to figure out and we can plug it in. We can plug it into the Charles Law. So here we go. So our volume is 42.3 over T1 371.15 is equal to our volume 2, oh, that's our X, because we don't know what that is, over 291.50. So this is our plugging in to Charles Law. What does that look like? Well, here is our V1, here's our T1, here's our V2, and here's our T2. This is what we got. Okay? Why is it doing this? Okay, let's go back to Zoom, bring it up to 100%. Thank you. Okay, so now let's bring it up to 100%. Okay? Come on. Okay, send the page. Here we go. So, now, for this one, guess what? It's a proportion. So we can sit there and cross, multiply, divide. That's it. Okay, so what are we cross multiplying? Like this, and like this. Perfect. So we have 371.15x is equal to, we'll do this one in red, 42.3 times 291.50. So this is what we have, ladies and gentlemen, as we're working our way through. Now, we're going to multiply this out, so very quickly we'll take our beloved calculator. 42.3 times 291.5 equals, so I get this giant number of 12,330.45 is equal to 371.15x. So that's our next step. Now we're going to get x by itself because x is our new volume, okay? That's what we're shooting for. So basic algebra, we're going to divide both sides by 371.15. So as we do that, then we're going to take 371.15x divided by 371.15x is equal to, 371.15x divided by 371.15 divided by, and over here it's 330.45 divided by 371.5. Okay, and we'll divide by 371.5 equals, and our final answer, 33.19 liters. Oh, milliliters, sorry. I think it's milliliters that they... Okay, let's take a quick look. Come on. And it's milliliters. So yeah, it's going to be 33.19 milliliters, and that's it for our first problem. Let's go on to the next one. The next one is 300 milliliters of gas at 17 Celsius. What is the volume at 10 degrees Celsius? This is a little bit more straightforward, okay? So I know that this is a volume. What is its volume? This is the second volume, just by tearing it apart. Here is a temperature, and here is another temperature. Now, how do we know which one is which? Well, I'm going to go ahead and say I am going to look for the keyword at, right here. So the ats connect these to each other, okay? That's what happens. So now we know how they're connected. We need to add 207. Now we've got that. So does it matter which one is which? I'm going to go ahead and I'm going to say let V1 equal X. T1 equals 10 Celsius plus 273 equals 283K. Okay, 283K. Over here, we're going to have V2. Well, what's V2? Well, V2 is 300 milliliters. So V2 is equal to 300 milliliters. And T2 is equal to, well, it's 17. 17 plus 273 equals 290. Okay. Okay. So far, so good. Now we have all our players. All we got to do is plug it in. We just got to plug that in. So here's V1 over T1 is equal to V2 over T2. This is Charles' law. Remember, pressure's the same, so you don't have to worry about it. Yes. Okay. So now with V1, V1 is X, so we're going to say fine. We're going to go X over 283 is equal to 300 over 290. And solve for X. Okay, not too bad because we can turn around and say cross, multiply, divide. Cross, multiply, divide. And again, we do the same thing. Cross, multiply. So let's go ahead with it. I'm going to say 300 times 283 is equal to 290 times X. Now notice I wrote this in green so that you know 290 times X. I wrote it in blue, 300 times 283. Okay, let's go ahead and let's figure this out. So 300 times 283 equals 84,900 is equal to 290x. Last step of algebra. Yes. All right, so we're going to say 84,900 divided by 290x. 290 is finally equal to x, because 290 divided by 290 is 1. Okay, so x is going to equal, well, let's see, divided by 290 equals, and we have 292.76 milliliters. That's, believe that would be it. Hold on. Let's check the units. Let's check our units here. Yep, it is in fact milliliters. So it's 292.76 milliliters. That is it for our final and second example dealing with Charles' law. Hey, I hope this benefited everybody and that you guys learned about it. So we looked at Charles' law where we kept the pressure the same. It had to absolutely stay the same. Otherwise, you can't use that formula of V1 over T1 is V2 over T2. You can't. We went over through 2 examples through that, and we came out with our solutions. I showed you how to do the cross, multiply, divide. And there you have it, ladies and gentlemen. I'm Steven Spielberg, signing off.